Hello, everyone, and welcome to Bicep for Real episode 11. This week, we're going to continue our work we've been doing around governance and testing and expand on some of that. So, if you remember last week, we looked at how we could test our templates against the ARM template toolkit to make sure we were following best practice. This week, we're going to go a step further and we're going to look at how can we test our infrastructure that we deploy with our template to make sure that it is actually deployed the way that we wanted to or we intended to, or it's in compliance with whatever rules we want to apply. As always, we're working on our Lambda Toys digital store project. We've got that deployed and now we're adding these levels of governance on top of that. We've got all our resources up and running and we're looking at our requirements here around how we actually make sure we're delivering what we said we would. So before we delve into that, we just need to fix something up from a previous episode. I wanted to quickly run you through this because this sort of came into what we talked about last week with PRs or pull requests. So when I ran our deployment this morning, we're getting an error around the deployment of the Azure Container app. And if we actually have a look at the error in the log, and if I can zoom in a bit, see how that goes. Yeah, so the error here, the total requested CPU and memory resources application is invalid. So we've asked for one CPU core and 1 gig of memory. That's not a valid combination in Azure Container Apps. You have to meet their combination requirements. So you can see we've got these various different options that were allowed. So what I've done is I've made a change to the code. And you can see here we've just upped the memory to 2 gigs so it meets that requirement for allowing it to deploy. Okay, so we've made that change. We've made it on a branch because you remember from last time, we can't commit straight to our main branch anymore to avoid breaking other people's things. So we put it on a branch and now we're going to do a pull request to actually merge that in. So if we head on over to GitHub, and often when you've recently pushed a change onto a branch, it will actually tell you that you've done that recently and do you want to create a pull request for this, which is what we want to do. So we're going to go to compare and pull request. And we're going to add a comment, something like of update ACA CPU to match required values. Okay, and we're going to go ahead and create that pull request. And you should see that this is now ready. And you can see now it's kicked off our tests. Remember from last week, we set up our PR test to validate against the TTK. So it's going to run those and it won't let us merge that until it is done. So we'll just wait for that to finish. If we have a look back over in Azure DevOps at the pipelines, we should be able to see that there is a pipeline running. And this one, and it failed for some reason. So let's have a look and see why this has failed. Failing test. And we've got some issues with the API versions being old. Let's have a look at this. So this is complaining about the Microsoft.resources/deployments being old. Now this is an issue with the actual TTK, and I believe I fixed it recently with an update. So let's just have a quick look at that. Okay, so I've checked that out. The issue actually was that I hadn't released the updated extension, so I've gone ahead and done that now, and we can look at fixing this. Now there are actually a couple of things here. We need to rerun this, but you'll also notice I can actually merge this change at the moment. So we've got an issue with how we've set up our policies. We're not requiring this check. So if we go look at the settings page and go into branches and look at our branch protection rules for the main, we're going to hit edit. And we see we've ticked the require status checks to pass for merging. We haven't actually told it which status checks we want to check. So we need to have a look at that. It's actually this one. I've renamed it a minute ago to make it read better, but it obviously hasn't flown through yet. So we'll just save that. Just go ahead and authenticate. Okay. So we should now, I think, be unable to merge this. Yeah, so I can't merge this without passing that test. Now we need to rerun it. So if you click on the details button, go in here and quick rerun checks. We'll just rerun them all. And that should start that process again. So if we go back to our pull request, you should see that these in a second will be in progress. There we go, it's running now. And we'll wait and see. Hopefully that will pass this time. Okay, so after a bit more fiddling with API versions, we got there. The PR has passed all the tests, and we're going to go ahead and merge that. I'll just leave the messages as they are. Okay, and that is all good to go. So on to the main topic of what we're going to talk about today. So we want to look some more at testing. If you remember last week, we ran some tests as part of our PR. where we ran the ARM-TTK against the existing code. And that gave us testing for best practices and make sure that we were writing good templates and so on. What that didn't do, though, is actually validate what we were deploying. So today's test we're going to look at is how do we actually test that what we deployed matches what we think we were going to deploy. So we're going to define our test to say, okay, this is what we expect to be available when we deploy our environment, and this is how it should be configured, and test that against what actually gets deployed. So these sort of tests allow us to validate that we are getting what we expect, but also to detect drift. So if somebody makes some changes in the future where they've changed the configuration of a resource or something that no longer matches our tests, the tests will fail, and either they're going to need to fix that so that the deviation is removed, or if that deviation was intentional, change the tests, but at least we're consciously making a decision that's what we want it to look like. Now, with Bicep and ARM templates, to test what we're going to deploy, we really have to deploy it. For other things like Terraform and Pulumi with a preview command, we potentially can do some testing against the preview resources. ARM and Bicep don't really have the same option. There is a what if command which gives you some output, but it's not really great for testing against. So what we are going to test against is actual deployed resources. We're going to have a look first at getting the tests written and tested against an existing environment, but then we're also going to have a look at actually creating an environment as part of our pipeline tests to run the tests against and then destroy afterwards. So we've got a clean environment to run our tests out, but we'll come on to that in a bit. First up, we're going to have a look at actually how we create the tests. Okay, so back in VS Code, I'm just going to switch back to main. Make sure that's all up to date by pulling that. And we're going to create a new folder in here called tests. This is where we're going to store our tests. And we're going to create another file in here. We're going to call it infra. Okay, so this is a PowerShell file you will notice. So we're going to use a testing framework for this called Pester. So Pester is a testing framework which you can write tests in, which uses PowerShell. So we can use the PowerShell language to create our tests, and it adds some structures and so on around the tests to actually facilitate that. Pester actually comes with Windows, it's installed, but the version installed Windows is very old and won't do what we want. So the first thing you need to do if you're going to use Pester, you want to test it locally, is to install the latest version, and you can see the docs here on the quick start guide. You basically need to run this install module pester-force command, which will overwrite the existing model with a new module, and that will get that installed and running. Now, a set of Pester tests is just some PowerShell, but with some extra constructs around it. So we're going to create a PowerShell file here. So the first thing we're going to do is we're going to add some parameters. So tests are a bit different generally to scripts. Tests, where you try and make scripts a bit more generic so you can reuse them, tests tend to be a bit more specific for the resources you're actually looking to test. Now, we are going to make this a little bit more generic by passing in some values, but not hugely. So we're going to create some parameters. This is plain old PowerShell parameters. It's going to pass in the resource group, where the resources you want to test are, and the prefix we're using in the naming. Those are the two things we're going to do to make it more generic. Now we're going to set up our tests, and this is where we get some of the Pester specific syntax for PowerShell. So the first thing is there are a couple of blocks that you call in Pester. Now, I'm not going to go into massive detail here on Pester, so if you want to get more knowledgeable of this, then there are some great courses online. I'll put some links in the video description, but we're going to go through a sort of basic setup we need for this. So the first thing is the sort of wrapper blocks that go around things. So the first one is called a describe block. So describe is just a keyword in PowerShell, and you give it a name. So the describe is a wrapper for your tests. So you can have multiple describe blocks if you want to break your tests up into things. So we're going to call these infrastructure tech, and let's do that. That's just a wrapper for all of our tests. Then inside that, we can have a second wrapper, which is called context. And this allows us to break up our tests a bit more. And we're going to break these up into contexts for each different type of resource. So the first test we're going to look at doing is we're going to be testing our resource group. And all that's going to really do is make sure that the resource group exists. It's a fairly basic test. Does the resource group with the name that we've passed in actually exist? So we're going to create a context block. And again, we give it a name, and we're going to call it resource group tests. Capitalize that, be consistent. And again, brackets, okay. And then within a context, you have its blocks. And so, as in IT. And these are there to describe the actual test that we're going to run. It uses the word it because it's supposed to be as part of the syntax, so you can read it as it has been created or so on. So we're gonna look at that. Okay. And then inside here we put our actual tests. And so this is where we just write plain old PowerShell to get the information we want to test at. In our case, because we're testing Azure resources, we're going to write Azure PowerShell data. So the first one we want to do is actually get the resource group. So we'll use the get az resource group command. We'll give it a name, which is going to be that resource group we passed in. And we are going to add the error action flag. And we're going to set that to silent. We continue. The reason we're doing that is we don't want, if the resource group doesn't exist and we don't put that, then when it tries to do this, it'll throw an error about the resource group not existing. It won't finish the test. What we want is the test to fail, not the actual command. And so what we're going to do now is, this is where we get some Pester specific information on how we evaluate the output of the test. So we're piping this to the should command. Should is a Pester command, and it has a load of parameters in terms of how you want to do your comparisons. So what we want to do here is basically make sure that the resource group is not null. So there's a not. We're going to use the not command, and then we're going to use the B command. The B command is a Pester specific one that says basically this should equal what's before what's coming through the pipe should equal what we're asking for here, which is null. Obviously, because we've added the not, that will reverse that. Okay, and that is your very first Pester test. And that's going to basically check that the resource group is existing. So let's go have a look at how we can actually run those tests. Okay, so we're at our command line here, and we're in the tests folder. You can see we've got the test file there. You can just run the test file directly, and that will run the Pester commands. But what we're actually going to do here is run the invoke Pester command. And we want to add a few options. We want to have the output be detailed. And then we're just going to pass it the name of the pipeline test we're going to run. And we'll go ahead and run that. And that's going to ask us for the parameters because we haven't specified those. We'll look at how we pass them in the command line in a minute. But we need to pass it the resource group name, which is this Lambda API dev resource group, and the prefix, which is this prefix here. And that will go and run our tests. And you can see that the test has succeeded. Okay. So that's a very simple test, just checking the resource group exists. Let's go look at a few more, slightly more complicated tests. Okay, so I'm going to copy and paste these so you don't have to watch my typing. But we're going to add another context block, and we're going to look first, we're going to have a look at virtual network tests. So you can see we've got another context block, named it virtual network. And the first thing we're doing slightly differently is we're adding this before all resource. So all of these tests are going to be done against a virtual network object. So we're going to have to use Azure PowerShell to go and grab that VNet and then run our tests against it. Now we could do that every time in the individual test, but obviously that takes time to actually go and run that PowerShell. So why don't we get the object once and use the same object for every test? To do that, we can wrap it in a before all block, which does exactly what it says. Before it runs anything else, it runs this command. It gets the virtual network, puts it in a parameter, in a variable, and then we're going to use that in the rest of the tests. So the first test is very similar to the one we wrote for the resource group. It's taking that VNet variable and again, checking that it's not null. Pretty similar. Next, we're going to do some tests against the subnets to check the subnets are configured correctly. And this is where you can see you can have should statements within a test. What that basically means is that when you run it, it has to pass all of those tests. It's an and approach, otherwise it will fail. So the first thing we're going to do is we're going to grab the count of subnets, and we're saying that should be 3. You'll notice that here we're passing in an integer. That's because B basically supports whatever the output of the comparison you're doing. So in this case, count is an integer. So we can pass an integer. If it was a string, we can pass it a string and so on. Similarly, with the subnets.name, there are multiple subnets in this test. So when you do the .name, it basically brings back an array of strings with the names in. So we're comparing that to an array of strings. Very straightforward. Get a little bit more complicated when we are then going to look at those subnets and we want to check that they are all the right size. So we're basically getting that subnets array, finding the specific subnet we're interested in this test, and then taking the address prefix, splitting off the / to get the end part, the /21, 22, whatever it is, and then we're comparing it to a 21 here. Now, turns out these subnets are all the same size. So I could have actually done this in a for loop and compared them each one in that array 2/21 and see if it came out of that. I did it this way because potentially you might have subnets that are different sizes, in which case it's obviously more difficult to do that through. So that's the virtual network. We're also going to add a test here for some Cosmos stuff. So again, let's add in a new context section for Cosmos DB. Same thing, doing a before all, but this time to get the Cosmos DB account. We're checking it exists. And then we're doing some checks to go and look at its configuration. We want to make sure that the Cosmos DB is set up with private endpoints and restricting public access so that we know that database is secure. So the first thing we do is check that it actually has some private endpoints enabled. We go and look at the private endpoint connection objects and see how many and check they're greater than 0. You can see we're using a different option here rather than B. We're using B greater than. So there are a whole variety of different comparison operators you can use within Pester. This is just the one we're going to use here. And then secondly, we're checking this is just a string comparison that the public access is set to disabled. So let's save all of those. And we'll go back to the command line and we'll run our test again. And we've got a failure. So all of our VNet tests have passed. Our Cosmos ones have mostly passed, but you can see here we've got a failure because the public network access is still enabled on our Cosmos DB. If we go and have a look in the Azure portal and we look in our resource group and Cosmos DB and networking, and you can see it's basically set to all networks, although the UI isn't showing it properly, but we need to get that set to disabled for our test to pass. So just for a second, I'm going to go ahead and save that. Obviously, we want to do this in code, so we'll go in and update our ARM template to actually, our Bicep template to actually reflect that. But short term, let's just test that and see that actually fixes our test. Okay, so that's updated. So if we go back to the command line and run our tests again, we should see that they all successfully pass. Okay, so that's some tests we've written. They work on the command line. That's great, but what we really need to do is get them integrated into our pipeline. So let's go have a look about how we do that as part of our testing process. Okay, back in VS Code, and we've done some updates here to run these tests as part of our pipeline. So we're looking at our PR pipeline. So we're going to run these tests when somebody submits a new pull request onto the infrastructure to allow us to test that they've not broken anything with the infrastructure we're expecting to be deployed. So this is our PR YAML, if you remember from the previous thing where we did our ARM-TTK tests. You can see for the minute I have commented out the ARM-TTK tests. This is not permanent. This is just during the one testing this pipeline. We've cut the pipeline down a bit and it's causing some TTK issues, so they'll be resolved once we publish that. So what we're doing is we've got a few tasks. So the first one, we have basically copied the same task from the main pipeline that deploys the infrastructure. We copied that in here, and we've just hard coded some resource group name and a configuration name with this infra test, and we've created an infra test configuration file that's pretty much exactly the same, except for the fact we've changed the prefix. We want a unique prefix for these resources. So this will go ahead and create a resource group called Lambda API Infra and deploy our infrastructure into that. Nothing terribly special there. The next bit is where we're going to run our Pester tests. This is just some Azure PowerShell that's connected. We're going to make sure that the Pester module is installed. We are setting some configuration values. So configuration allows us to sort of create the settings we're going to use for the Pester test. So in particular, we're outputting the results, and we are telling it where to output an XML file that has the results of our test. That's where we're going to then pull them into our testing UI later. We've got this container. So you remember when we ran it from the UI, we had to pass in the parameters interactively. Well, obviously that won't work. A container is basically how you create a Pester container that has the path to the Pester test you want to run, but more importantly has this data object where we can specify the parameters when you're passing. So we're passing in the resource group name and a naming prefix. Again, hard-coded because we want to use the same ones. Then adding them to the configuration, and then we run invoke Pester with that configuration to run the tests. We send an exit code with the amount of failed tests. That then means if there's no failed test, exit code 0, all good, and it gets a green tick. And if there's any more than 0, it will fail, which is exactly what we want. Then we've got our publishing of the test results. This is nearly identical to the one that was already there. We're just adding in an additional test to look for this test infra XML file. And then the last step is we are cleaning up some of our resources. We're deleting that resource group so we don't have the resources hanging around anymore. They're just there for the test. So realize we missed something. We need to add this condition here as well, because we want to make sure that our resources are always cleaned up, even if the tests fail. Okay, so that will then run all those tests as part of a PR. Back over on the pipeline, we've got our deployment we just ran here. So this has run all those tasks. If you have a look at the job, you can see it's run through those. And if we go have a look at our tests, we can see they all passed. And if we tell it to show us the passed tests, you can see we've got the tests that we wrote earlier, that it has created the resource group, the subnets. So all those tests we're running as part of the Pester piece as well. So we've now got our PR process, which will run the TTK once I've uncommented it and put it back in again, which I'll do in a second. It will then deploy a whole set of resources. It will run our Pester test to check those resources are what we think they are. It will publish the test results of those, and it will delete those resources so they only exist for the period of the test. This is really useful to make sure that any PR anyone submits is going to pass all the tests before we merge it. There is a downside to this, obviously, because we're deploying those resources, it takes time. And the more resources or the more complex resources, the longer that can take. And so it can cause some issues in terms of how long it takes a PR to go from being submitted to being approved, because you've got to wait for those tests to run. You need to balance that against the value of having those tests run against it. Up to you how you do that. Similarly, you could run it as an overnight test or something else rather than running it against a PR. Up to you how you wanted to configure it, but this is how we do it. Okay. That kind of sums up the sort of governance and testing piece we're going to do here. Next week, we're going to come and have a look at some areas around modularization and reuse of code. As we get towards the end of this course, we are going to see how we can build our code with best practices and modularization so that we can reuse it later or share it with other people in our team. So hopefully I'll see you for that session, and have a great rest of your day.